My name's Joe Duffy, founder and CEO of Pulumi, and I'm super excited to welcome you here today. Amazingly, we just celebrated our 8-year anniversary here at Pulumi. We started back in 2017 with the vision to democratize the cloud and just make it so much easier, more accessible, fun, and powerful. And I'm proud to say that, we're doing just that. We also launched PulumiUP first 5 years ago, and we've done it every year. It's one of my favorite times of year. We get to celebrate you, the community. Always some exciting new product announcements, and we won't let you down this year. And talk about what's next, what's on the roadmap for us. As part of democratizing the cloud, we wanted to bring the entirety of the cloud to your fingertips, and we did that by supporting all clouds and all languages. We took a different approach for infrastructure as code, where we stood on the shoulders of giants and used general purpose languages like Python, JavaScript, TypeScript, Go, Java, and yes, even YAML. We now support over thousands of clouds. We've gone from hundreds to thousands over the last year, and that includes public clouds like AWS, Azure, Google Cloud, private clouds like vSphere, cloud-native technologies like Kubernetes and Helm, even SaaS providers of infrastructure like Cloudflare, MongoDB, Snowflake, Datadog, and others. Thanks to this innovative approach to infrastructure as code, Pulumi is now the most vibrant open source infrastructure as code technology in the ecosystem. Even compared to OpenTofu and Terraform, we see more than 2 to 3x the engagement across key open source metrics like pull requests merged, issues closed, and more. We now count over 350,000 members of the Pulumi community and have seen over 1 million downloads per week, both testaments to the amazing growth and excitement around Pulumi's open source ecosystem. And it's been a busy year for us here at Pulumi. We ship a lot. I think on average, we ship 1 to 2 times per week. You just go check out our blog, a lot of exciting things there. You can go back in time and see what we've been up to. That includes trying to be the best infrastructure as code we can for you in the community. We've recently improved our component model, so it's easier to create infrastructure abstractions that you can share and reuse in your team. We introduced a new policy violations page so you can see where your infrastructure is or is not compliant. We introduced support for any Terraform provider. So if there's a Terraform provider in the ecosystem, you can plug it into Pulumi, use it from your favorite language right away. We added customizable naming schemes to improve zero downtime deployments with more flexibility. We've introduced support for an array of new tools in the language ecosystems, including Python with rich package managers, better typing, IDE support, and more. And we continue to improve the performance of the core product, including radical changes to the way that we encrypt and decrypt secrets, so that as you're sitting at your CLI typing away, things are as quick, fast, and enjoyable as possible. We're also working to make migration easier. We know that a lot of folks want to get to a world of 100% Pulumi, but have some legacy that they have to deal with. And so we vastly improved the ability to convert existing Terraform code bases entirely over to Pulumi in your favorite language. And that includes even porting Terraform modules to Pulumi components. We've also embraced the ecosystem by supporting a wide array of other integrations that, we would not be Pulumi were it not for all the cloud providers, all of the other tools that we integrate with. That includes Azure Native 3.0, which is a vast improvement to our Azure provider, which already has nearly 2x the coverage compared to the Terraform Azure provider. That means the full entirety of the Azure platform is at your fingertips. Improve the performance there by 75%. So the size is much smaller, even though we support the entirety of the Azure platform. Pulumi Java is now generally available. We've launched, as I mentioned, we've gone from hundreds to thousands of cloud providers in the Pulumi ecosystem in the registry. We launched significant improvement to our Kubernetes operator, which we call 2.0, which allows you to actually orchestrate Pulumi deployments from within Kubernetes clusters using CRDs. We shipped a new EKS provider for best-in-class support for AWS EKS. And we dramatically improved GitLab support in the product. So if you're using GitLab for source control and CI/CD, Pulumi Cloud is going to feel that much more natural. We brought AI and the best of large language models to your infrastructure. That started with Pulumi Copilot that we shipped last year that allows you to generate infrastructure as code, but more than that, gain insights into your cloud infrastructure and ask questions from very basic ones like, where is IP address 1.2.3.4 to what is my most expensive, least used resource. We brought that into Visual Studio Code, so you can have Copilot sitting there with the context of your full application code. And more recently launched a Model Context Protocol server, MCP server, which allows Pulumi to plug into your favorite vibe coding tools, including Claude Code, Windsurf, Cursor, VS Code, and a growing array of tools that support MCP. We also launched new products. We launched ESC, which stands for Environment, Secrets, and Config. This is Pulumi's approach for how you manage secrets and configuration at scale, both for applications and for infrastructure. We've recently improved that with secrets rotation so that if you have static long-lived secrets, you can rotate them. Of course, we prefer dynamic short-lived secrets, and we've made those even easier to use as well. It includes Pulumi Insights as well, which is a really exciting new product. A lot of our customers are very excited about that. Really, this is basically like turning on a flashlight in a dark room and suddenly seeing all the cloud resources you have sitting everywhere. We'll give a complete audit inventory of everything that you've got in your cloud estate across AWS, Azure, Kubernetes, any cloud. We'll give it to you in a easy to consume form so you can see what you've got, slice and dice it, search it, ask questions using Copilot. And we've also added the ability to run policy enforcement across all of your existing resources. And with that, we've actually crossed recently 3,500 customers, which is an amazing milestone. So thank you to every one of our customers that I know are in the audience today. These customer case studies, which you'll hear a few of the stories today, span some incredible success stories. The things that folks have been able to build with Pulumi that they couldn't have otherwise are just game-changing for their businesses. That includes Snowflake innovating with their data cloud and rapidly incorporating AI capabilities into their own product. NVIDIA, who's managing some of the largest GPU-loaded clusters known to the planet. Moderna, who is radically innovating in vaccine development and R&D, and able to empower their data scientists to really tap into the cloud to save human lives, literally. And BMW, who's reimagining the modern car in a cloud-first era. And with that, I'd like to welcome a customer to tell us a little bit about how Pulumi has changed their lives. So introducing Daniel Kisselman, DevOps Tech Lead at XM Cyber.
I'm working at XM Cyber. We're based in Israel, in Tel Aviv. Okay. The company was founded in 2016, and we've been running for almost 10 years now. We're a part of Schwarz Group. It's a big retail company based in Germany. We run multi-cloud. We support AWS. We will support soon GCP. And also we support Stack IT, which is a European cloud provider, which is developed by Schwarz Group. We seeked a new solution. We seeked something that can give us enough agility and can give us the solution we need for those scenarios. And Pulumi came in rescue. First, we started writing in Node.js, in TypeScript, our Pulumi programs. And then as our team grew, we moved to Python, and we're writing Pulumi ever since in Python, and we're loving every minute of it. We actually took it, I think, to the next level by leveraging the Python packaging. We have actually some plans in the future to create an actual developer platform and use it. And of course, Pulumi will be the backbone of this.
Well, that was great. We heard how XM Cyber has successfully used Pulumi to codify their infrastructure abstractions using Python. And you heard Daniel say they've been loving every moment of it. And that's something we hear a lot from our end users. We like to say Pulumi is the cloud infrastructure platform that engineers love and enterprises trust. And that love part is very important to us. That's where we started. With Infrastructure as Code, our open source tool, we really put every thought into every little detail of making sure the end user experience was amazing and productive and felt fun to use. But we know that's not enough. We need to marry that with a platform that enterprises trust. And that's why a lot of the capabilities that I highlighted that we've been working on over the last year are very important. They brought security, governance, compliance, robust enterprise level controls so that you can love using the tool, but you can also adopt it at vast enterprise scale. So that's what we've been up to. Let's now talk about what's new. Today, I'm super excited to announce 3 major additions to the Pulumi platform. The first is Visual IaC Import. Using Visual IaC Import, you can bring existing cloud infrastructure under the management of Pulumi IaC. You simply point Pulumi at your existing cloud accounts. We'll tell you what's there. You can filter and group and select things. We'll even discover related resources and dependencies that you might not know about. And then with a few clicks of a button, you can generate code in your favorite programming language and even use AI enhancement to improve the code, whether that's stylistic, making it more in the style that your organization uses, or just cleaning up names and formatting. From there, you can download the code, add it to an existing project, or create a new one, and import the state. And from there forward, Pulumi is managing your infrastructure. With a few clicks of a button, you've gone from chaos to complete IaC management and automation. So we're really excited about Visual IaC Import. The second capability is the private registry. Just like the Pulumi public registry, the private registry gives you one single source of truth for a set of building blocks within your organization. That includes components, templates, policies, and documentation for all of them. Using the private registry, you can manage the artifact lifecycle, including semantic versioning for all of your building blocks. You can gain organizational insights into how your team is using the various building blocks in the registry, and enable easy sharing, discovery, and reuse of the patterns and practices you'd like to use within your team. And third is Pulumi IDP, an entirely new product to add to the Pulumi family. IDP stands for Internal Developer Platform, something many of you are very familiar with. And what Pulumi IDP does is takes all of the amazing building blocks, all of the amazing capabilities we've been talking about, and wraps it up in an IDP product. That includes giving you the ability to codify and enforce organizational standards as a platform team, including components, templates, policies, leveraging the private registry. It allows then end users of the IDP to flexibly spin up and manage infrastructure with built-in guardrails. These end users can, of course, be developers, data scientists, or anybody in the organization that wants an easy way to provision and manage their infrastructure. When I say flexible, there are many ways you can consume the IDP. The first is full no-code. In this mode, you can click in a UI to spin up the infrastructure, configure it, redeploy it, without ever having to know that it's powered by IaC under the covers. There's low code, which is the ability to configure infrastructure abstractions using YAML and deploy it using CI/CD pipelines, Kubernetes operators, or any tooling of your choice. Then, of course, there's full code. Many organizations actually want their IDP end users to be using IaC, but in this case, they can use different languages than the platform team has chosen to use. Maybe the platform team has created their components and templates in Python, and end user developers are using TypeScript to consume them. And finally, everything with IDP in true Pulumi fashion has a REST API. And so it's fully extensible, customizable, and can integrate with your custom tools and workflows. Pulumi IDP doesn't stop on day 1 and 2, however, it goes well beyond that. You can detect and remediate policy violations, drift detection as well. You can perform change management as you roll out new components and templates and understand who's using what in the organization and ensure that things are always compliant, always secure, and you can find issues before performing your rollouts. And then finally, we're launching Pulumi Identity and Access Management, IAM, which is the next evolution of the Pulumi security model that builds on top of our identity and RBAC model and extends it with custom policies, roles, and attachments for the entire set of building blocks in Pulumi IDP. So those are the 3 announcements. Let's dive into some demos. To tee this up, we're going to have a little bit of fun, a little bit of role playing. We're going to pretend that we are an engineering team at Initech, and we're going to set up a platform, and we're going to do it real time and show you how to do it with Pulumi IDP and Registry and everything we've already seen today. I'm going to kick us off, pretending I'm the CTO at Initech, trying to get a lay of the land and understand what this is going to entail. Then Komal, who's an engineering manager at Pulumi, will play the role of the platform engineer, and Megan, who is general manager of IaC here at Pulumi, is going to play the role of software developer at Initech. It's a little bit of fun, but hopefully informative. And to set the stage even further, this is a common situation in organizations that we work with who are going through a moment of change where the cloud has become the bottleneck or they're not able to move fast enough. Especially today in this AI-fueled era where we've got to ship code faster than ever before, it's got to run in the cloud, it's massively distributed, everything is just moving so much faster, and the organization needs to be set up to support that speed, and yet we know security is paramount. We can't be suffering security and governance issues. So the conundrum is, how do we move fast with built-in guardrails so that we have that security and governance assurance that something's not going to go wrong? And so our CIO here at Initech has passed down a set of requirements. We've got to have full visibility and control into everything we do. We've got to make sure that nothing violates the policy, that everything is secure and governed, that risky changes are approved by the right people, that we're using the principle of least access. Everything's got to be automated and reusable, so we're not copy and pasting, that we're actually using patterns and practices that the security team can review and sign off on. No manual changes, and developers need to be in the driver's seat. They need to have a great developer experience. They need to be efficient. The only way to move at the speed of modern business, especially in the AI first era, is to let developers ship code faster than ever before. And so we're going to get all this done in the next few minutes. And I'm going to get started. Let's dive in and see what we're dealing with. Okay, before Kamal builds out our platform and Megan uses it for developer self-service, I'd like to see what we're starting with. Most folks coming to Pulumi would start with the infrastructure as code CLI, but we've already got a lot of legacy tech debt. So I'm going to start in the Pulumi Cloud Console. You can see that my team is already signed up and is already deploying things and spinning up resources. But we're going to head on over to Pulumi Insights, where we can get a quick view into the state of our existing cloud accounts. The dev sandbox is already hooked up, but we're going to go ahead and create a new account, select AWS, and we're going to take a look at the Initech staging environment, where I know we've got some resources that need to be cleaned up. Kamal has already set up an IaC environment for us, so we can quickly authenticate using short-lived OIDC dynamic credentials. We're going to click Create after selecting all the regions, and a scan has already been kicked off. Pulumi Insights is now discovering all of the resources that already exist, no matter how they were provisioned. With Pulumi, Terraform, CloudFormation, manually pointing and clicking in the console, we don't really care. And we can see that resources are starting to show up. They'll incrementally load as we go. Let's head to the resources page where we can now see the details of all of the resources being discovered. We can group by properties like the category and type to easily understand what we have in our account. For example, we can see here we have 936 S3 buckets. We can also drill into the details. We can group by other more interesting properties too, like when was the resource last modified? We can now see in the last 24 hours, we've had 96 resources that have been modified and over 3,000 resources that haven't been modified in over a year, probably indicating cloud waste. Next, let's check out the policy violations page. This shows us which resources are violating policies, even for resources not yet managed by Pulumi. We can filter by account to see that we've already discovered new policy violations in the account we just began scanning, including an ECS task that's consuming too much memory. Or we can just take a holistic view at all the violations across all of our accounts with grouping and sorting. We can see here we've got a lot of issues with tagging. In our organization, we require department tags so we can always know who owns what infrastructure. Let's go ahead and fix some of these violations. First, we're going to get it into Pulumi IaC. To do that, we'll use the new Visual Import tool that we just launched today. Go over to the Import tab, and then type in a search to filter down to the resources that you wish to import. Here, we're actually using natural language to find all of the resources owned by Milton. There's only 2, but they seem to be missing the other department tag, which is required. We'll select them, click Next. Pulumi will infer all of the related resources that we might actually want to import, but for now, we'll deselect them and stick with just these 2. We can see here it's generated the code. We prefer Python, so we'll select that. This clearly is auto-generated code. I think it can be nicer. We'll click Enhance to use AI to automatically comment and make sure the code is clean. And then from there, we can copy the code and head on over to VS Code. We'll import these resources into a brand new Pulumi project. We run the Pulumi new command to scaffold a bare bones AWS Python project. It'll install all the dependencies. We can go paste the generated code into the main.py. We want to deploy to the US West 2 region, so we'll set that up now. Kamal has already conveniently set up an IaC environment that we can use for short-lived OIDC AWS credentials. Let's check out the code briefly. You'll see these import statements, which tells Pulumi to import the resources rather than creating new ones. You'll also see we get great statement completion, including Copilot in red squiggles when we make a mistake. This is going to be a massive productivity win for the entire team. Now let's drop down and run PulumiUP to perform the import of the resources. This doesn't modify the state of any of our cloud infrastructure. It just brings it under the management of Pulumi IaC, so that from this point forward, it's IaC managed. Now for those pesky policy violations. Pulumi's new MCP server integrates with many AI tools, including GitHub Copilot right here in VS Code. We're going to ask it, do we have any policy violations? It's going to run Pulumi and find them, and then it can help us actually fix them. We'll ask it, yes, please fix these violations that you found. We'll also tell it what our department should be. We're late on our TPS reports, but we're in that department, so we'll tell it to tag it TPS reports. And Copilot goes through and actually edits the code, adding the missing tags. Then it deploys the changes. So right now, it's actually patching our infrastructure and adding the missing tags, and now we're fully in compliance. Now for one last task. It's a real shame we've got all of these ad hoc resources everywhere with mistakes and lacking the best practices. I wonder if we can use the Pulumi component model to start cleaning some of this up. We'll ask AI to help us with this too. We'll tell it to refactor our cluster and service into a component so it's easy to remember to include best practices like tagging. And what do you know? It's gone through, refactored the code, derived from the Pulumi component resource. But you know, this is just scratching the surface. There's so much more we need to do. All right. Well, slightly chaotic mess, but I think we have a path forward. So what did we see? Just a quick recap. We saw that we could get full visibility into everything that we've got in the cloud already before even adopting Pulumi IaC or IDP using Pulumi Insights. We quickly identified that we had resources that were violating our policies. We easily imported those resources into Pulumi IaC using the new Visual Import capabilities. And from there, we were able to use the great tooling support with VS Code, our policy extension, and some AI assist to fix the policy violations and remediate them, and refactor the code and get it ready for our new platform. But we're not stopping there. I'm an amateur. It's time to bring in the experts.
Thanks, Joe. Hello, everyone. My name is Komal, and I'm a platform engineer here at Initech. As a platform engineer, my focus is making infrastructure self-service, secure, and cost-efficient so development teams can ship features fast without getting bogged down in ops. Today, I'll show you how to create a secure, cost-controlled infrastructure component, publish it to our private registry, wrap it in a turnkey template, and safeguard it with policy as code. Let's get started. One of the basic building blocks of infrastructure for the development teams at Initech is the trusty containerized application. It's such a useful pattern, but has quite a few moving pieces that our developers shouldn't have to worry about. So let's talk through it. Over here in my IDE, I have my component defined in Python. This file has nearly 400 lines of infrastructure code and includes resources like a private VPC, subnets, security groups, all of the ECS resources, secrets and secret manager, and ALB, etc. All of this is important to make sure our applications stay secure, but that's definitely a lot more infra code than our developers want to keep track of. So instead, we've exposed a very simple interface to our component, narrowing it down to just the things that are important to our developers, like where the application is located, what port it's running on, environment variables and secrets, and some tags for the resources. Now, to publish this command, all I need to do is run Pulumi package publish and pass in the URL of where the code is stored in source control. In my case, I'll pass it a GitHub token, since this is a private GitHub repo, point it to a README, and pass in the name of my org as the publisher. Now, let's pop over to the Pulumi Cloud UI to see what this looks like in the console. We'll pop over to the new Components tab, where I can see all of the components that are published to Initech's private registry. Let's click in to Container App, since that's the component we just published. In the README here, we have instructions for how this component can be consumed, code samples for how to use this component in Python and YAML, but of course, this component can be consumed in any supported Pulumi language. And down here, we have the API docs, including all of the inputs and outputs of the component, their types, and their descriptions. Okay, great. Now we have a container app component. It can be easily initiated with just a few inputs, and our developers can use it to deploy any of their apps. I think we can make this even easier, though. I've noticed a lot of our teams spinning up AI chatbots that use a pretty standard pattern and all need access to an OpenAI API key. So we can wrap this component we made into a template, providing the developers with some standard boilerplate code to get started. Let's head back to the IDE. I'm going to navigate over to the template directory where we consume the component that we defined earlier. So that's this chatbot container app TS directory here. This is the infrastructure file, and you can see the complexity of 400 lines of infrastructure has been transformed into the sweet simplicity of these 27 lines. You might also note that this file is in TypeScript, since I can consume the component in any language Pulumi supports. Most of this file just lets the template direct configuration directly to the component, but there are a couple of specific things I want to point out. We have a system prompt here that lets the user define a custom system prompt to pass to the application, to include with every API request. Another thing I want to point out, we're passing in an OpenAI API key so the application can connect to OpenAI. Now, let's pop over to the app directory, which contains some starter application code. Here you can see the system prompt being read in and passed to the API. The benefit of a template is that I can wrap up all of this boilerplate code alongside the component so the developers have everything they need to get started right away. Let's pop over to the UI again to see what this looks like. Now I'm in the templates directory in the templates tab of the Cloud UI. These are all of the private templates that are available to the InnoTech organization. Let's take a look at Chatbot Container App TS, the template we defined earlier. Here we have the README for the template, once again including the installation instructions. In this case, all I have to do is run Pulumi new followed by the source URL. Once again, I'm passing in the GitHub token because this is in a private GitHub repo. There's some other information here like the configuration and outputs available from the template. All right, now let's talk about secrets. Our template needs AWS credentials and an OpenAI API key. We already have a couple of ESC environments set up that contain those keys. We have the OpenAI environment that contains the API key, alongside the Dev Sandbox environment that uses OIDC to generate dynamic credentials to access our AWS accounts. Now, the common chatbot secrets environment imports the two environments that we just mentioned, merging them together to create the exact shape of configuration that we need for our template. It has the environment variables for AWS credentials and the OpenAI API key set as Pulumi configuration. Lastly, let's talk about compliance and cost controls. We want our developers to have flexibility, but we need to make sure our costs don't balloon out of control. So we've deployed a policy pack that lets us configure some policies like required tags and max values on certain properties. We'll head back to the IDE to show you the code for this policy pack. Our policy pack is configurable. It has two policies, one that allows configuring some required tags for our resources, and another one that lets us set limits on CPU and memory for our ECS tasks. Note that the limits are not set here. Those are configurable in the UI, which I'll show next. Here we can see that this policy group uses the policy pack from the code, but this is where we've configured the actual policies. So we've required that our resources include the department tag, and we've set a max limit for memory for the ECS services so we can be alerted if any services exceeding that memory limit are deployed. The flexibility of configurable policy means I can set different limits for different stacks, since I might want my production stack to have a higher limit than those in development. And that about wraps it up. At InnoTech, we've shaped our internal developer platform around our top priorities: speed, cost control, and strong security posture. Because Pulumi exposes every layer as code, we can encode those priorities directly into the platform's building blocks, giving developers guardrailed self-service without sacrificing what matters to us. And there you have it. We've turned a complex ECS containerized application into a single reusable Pulumi component, wrapped it in a template, and safeguarded it with policy as code. Now I'll hand it back to Joe to kick off the next demo.
Thank you so much, Kamal. That was amazing. Let's recap what we saw. We saw capturing our team's best practices using a reusable component written in Python, creating a template for new projects so that it's easy to access those components from the IDP. We defined policies to enforce governance, ensured full automation and full security of everything that our team is doing. And we configured our team's IDP so that it's ready to go. And next up, we're going to see that IDP in action. Welcome, Megan.
Thanks, Joe. Hi, everyone. I'm Megan, a software engineer on the InnoTech development team. Today, I'm going to show you how to go from zero to a full policy compliant service using the Pulumi IDP. Now let's dive in. Today, we're going to deploy an AI assistant for our public website using the chatbot container app component that Komal just wrote. First, we're going to do so from the UI without touching any code, and then from our IDE using Pulumi code. So I'm starting in the Pulumi console. The first thing I want to do is under Pulumi IDP, click Templates and filter it for my use case. So I'm going to go ahead and do that, and I'm going to scan what our best practice abstractions are and pick the chatbot container app because that's the one that makes most sense for our use case. I'm going to read through the README and try and understand if it achieves my objectives, like having the OpenAI API key. Okay, this looks exactly like what I need. Let's deploy it. Now, jumping in here, we want to change the project name to the public website chatbot app, and I'll paste in here a description for our project. I want to keep the stack name as dev, and I'm going to select the deployment method here. Now, the no-code deployment means that Pulumi Cloud manages the code, and all I have to do is update the configuration from the UI. The get backed one will just point us at the branch, and the CLI deployment I could just do locally. Next, looking at the right-hand panel, I'm just going to type my name in the owner in our configuration panel here, and I'm going to paste in a system prompt that will make this tuned to be our public website AI bot. So it's going to answer questions about the company and its products. And the last thing I have to do is grab our secrets in our IaC environment, which has both our application secrets and our infrastructure configuration details. So now that that's deployed, I think I'm going to go and stamp out a staging stack while I'm waiting for this to deploy, because it does have a container in it and it will take a while to get going. So I navigate to the project page and add a stack. So as you can see here, it's quite easy to be able to just stamp out the different instantiations of each template. And then all I have to do is add this metadata in my configuration values. I can also update this metadata if I wanted to, let's say day 2, change something about the prompt or tweak it. I can edit that from Pulumi Cloud. Now let's jump into the IDE. Here in the IDE, you'll find a Pulumi YAML program. And in this program, we're referencing the same component that we were deploying from the UI. So you can see here the properties, similar to what was in the UI. And these are the ones that I thought were most relevant, so I had them in here. And if we look in our app.py file, you'll see that I moved the system prompt into the Python file as I'm locally developing and just wanting to run the Python file. Now, I've asked AI how I can increase memory to make this handle the scale of our public website. And so I just said to the inbuilt LLM in Cursor, which is Claude, in this case, hey, how do I make this scale to be massive? And it's gone ahead and said, all right, you want to increase your memory to 8,192. I run a PulumiUP on this, and we should be up and away. Oh, but it looks like actually we hit some policy violations, and they're just advisory, but if I went to do this in production, it would be mandatory and I wouldn't be able to deploy. So the first thing is we're missing the required tag department. Right, I forgot about that. Cursor helps me out here and auto populates it for me. But our platform team requires this so that they can do cost tracking in our organization. So everything needs to be tagged with it. The second policy violation we have here is that the ECS test is taking too much memory. And so we have an upper limit of 4,096. So let's just paste that in and stick with what our platform team recommends as the maximum we use. So let's go ahead, run a PulumiUP again, and see if now we can get a clean deployment. And so as you can tell, I've used AI for this, and I've been able to move quickly, but also stay within the guardrails of our policy. Now, while we're waiting for this to deploy, because it will take a bit, let's go and test the endpoint that we just created from the UI, because that should be up and running now. So I'm just going to paste in a curl command that I've written that references the URL from our last container at the chat endpoint. And so I'm asking it, what can you tell me about your company to test that it got the prompt correctly and it's ready to be used by our front-end code? And so you can see that it's talking about Initech code. So everything's working as expected, and it explains what our company does. And so now we'll be able to reference this. We'll be able to use this endpoint in our front-end code, and the service is up and running. And we've done it from both the UI, but also from inside code, and been able to find success here. So the last thing that I wanted to show is going back to Pulumi Cloud, our concept of a service. And so in a service, you can have, it's a container for all of your entities within Pulumi. So in this case, I would probably want the stack we're looking at. I would probably also want the environment we use, so I have all the configuration and secrets. And you'll find the services under the left-hand navigation under Pulumi IDP. Now, other types of things that you can put in this container is your links to things, and you can even have like documentation and strings for any customization on what you might want to tag them with. But so on the right-hand side, you can see we've added our app URL. You can see when the project was created, the description for it, and that I'm the owner. And this will now be my dashboard for me as an application developer coming into Pulumi. I'll just want one page where I can see all the helpful information. And one of those things is my ECS metrics dashboard, which I'm going to want to be able to keep an eye on how my cluster is doing now that it's live, and see what the utilization is, make sure that it's healthy. And so I have this all as one single source of truth, one place that I can go and get all of the reference material for my project.
And there you have it. Self-serve, no-code stacks that I can either click to deploy or eject into code and customize. We benefited from the speed of having reusable infrastructure patterns ready out of the box, but we were able to stay compliant with the policy guardrails. Now I'm going to hand it back to Joe, who's going to wrap up what we've learned today.
Thank you, Megan. It's amazing seeing Pulumi IDP in action. Let's recap what we saw. We saw that we were able to create a Pulumi IDP service that holds all of my application's building block entities that were defined in the Pulumi registry. We deployed cloud infrastructure with no code, low code, full code. We were able to easily reconfigure and redeploy and benefit from built-in guardrails and governance. And at the end of the day, developers are self-serve, productive, and still secure. And I think we're going to make that CIO happy. So with that, just a quick recap of the Pulumi IDP core concepts. Services are sort of containers of all the building blocks that your IDP end users are spinning up, managing. It's one place to go to collect all of them together. You've got components, which are the infrastructure abstractions powering everything behind the scenes with Pulumi's very powerful infrastructure as code engine. There are templates, which are blueprints to scaffold new projects. Policies, which cross-cut all of the above and ensure that you're following your organization's best practices at all times. You've got a self-service portal where you can see what's available to you and what's up and running. You've got Pulumi IAM to make sure that you've got rich, secure controls over all of those building blocks. The ability to include links to observability dashboards and approvals to make sure that we're able to empower the right people, but with the right guardrails and right checks and balances in place. And although Pulumi IDP works great out of the box and you can get up and running with a platform in a day rather than a year, we still love our building blocks here at Pulumi. Everything we do is customizable, extensible. We've got a rich data model and REST APIs, so you can program your IDP the way that you need to. It can integrate with what you already have if you have custom integrations and backend systems, CI/CD pipelines, etc. It also integrates with other portals if you have Backstage or custom UIs. We, in fact, have a custom reference architecture that we've put up on GitHub that's open source for you to check out if you want to see how that might work. And the result is a fourth addition to Pulumi's product portfolio. And of course, as with every product, each of these is independently adoptable, independent of the other, but work better together and share the common REST API security model, data model, and capabilities like Copilot, CrossGuard, and Workflow. And everything we've shared with you today has been informed by real-world IDPs that we're seeing our customers build, like Clear. James Forcier here at Clear is a staff engineer, and he'd like to share with you how Pulumi has helped them build their IDP at Clear.
I think our usage of Pulumi kind of falls into two categories. One is just the base like IaC tooling that we provide to production engineering to build, whatever custom IaC tooling they need for very specific use cases. But something that we spent a lot of time on as well is essentially just what you described, an internal developer platform where instead of having, our centralized infrastructure repos where there's huge blobs of Terraform that developers have to maintain and care about, we move those configurations into the service repos themselves, which is a big win for our developers, right? They don't have to go hunting around in multiple places to find where their infrastructure is defined. It's just right there in the service code. And we also moved from a sort of lower level Terraform and HCL based interface to something built with Pulumi. We're looking at condensing what is about 150,000 lines of HCL down to probably an order of magnitude smaller in terms of both code and config in Pulumi. Right off the bat, having just less to manage there, and in particular, less for our service teams to manage, right? A lot of that 150,000 lines is service infrastructure that's not directly owned by us. And that's a huge burden for service teams to have to manage a lot of HCL and infrastructure code that isn't really in their day-to-day sort of wheelhouse. So being able to consolidate that down to something that's a lot easier to manage and audit and review as well is a huge benefit.
So you've heard from James there how using Pulumi to build out their IDP enabled them to put developers in the driver's seat and accelerate innovation while still having the confidence and compliance that they need. Pulumi really helps to unite the entire software engineering team, starting with the platform team, allowing them to define their best practices, review them with the security experts, and make sure that they are secure and compliant and staying up to date as they need to, and then going and empowering developers to be self-serve and innovate faster. And that's a wrap. That's everything we've got to share today. We're really excited about Visual IaC Import, the private registry, and Pulumi IDP. If you'd like to try out anything you've seen today, go to pulumi.com. Of course, it's free to get started. And most of what you've seen today is live today, and anything that's not there will be coming out in the coming days and weeks. And I'd like to extend a sincere thank you to our customers and partners. Without you, today would not have been possible. That includes AWS, Docker, GitLab, Honeycomb, and Temporal. Also, we're launching a new platform engineering workshop series that's beginning tomorrow and extending throughout the spring. So please join that if you'd like to understand how to use Pulumi for platform engineering, including building IDPs. And that's it for me. We've still got some exciting customer talks and panels throughout the day that I hope you enjoy. Thank you for joining PulumiUP 2025. Can't wait to see you next year.